Hello and welcome to the Chapter 18 movie focusing on blood vessels. So first there's two different circuits. We have what's called the Pulmonary Circuit, which takes blood out to our lungs to pick up oxygen. And you can see red means it's oxygenated, blue means it's deoxygenated. And then we have the Systemic Circuit taking blood out to the rest of the body, where it delivers oxygen to our tissues and it brings back carbon dioxide. There are different types of blood vessels you need to know. First, arteries. And here's an artery. And here's a vein. You can see the artery, here they are under a microscope. You can see the artery's thicker, has a thicker wall, but the vein has a bigger diameter. Arteries always carry blood away from the heart, and veins always carry blood towards the heart. And arteries and veins are made up of three layers called tunics. So the tunica intima is the innermost layer. You can see it in the artery and the vein. It provides a smooth surface for blood flow, and in arteries it contains an internal elastic membrane because arteries have to be stretchy. Then you have the tunica media, which is a smooth muscle layer for constricting or dilating blood vessels. You can see it's much thicker in the arteries than in the veins. And then the tunica externa is pretty similar in both. It's the outer connective tissue sheath. So let's look first at arteries. Arteries always carry blood away from the heart, and they have a high pressure. Elastic arteries, you can see here. Elastic arteries, these are the largest arteries leaving the heart, and they can withstand large pressure changes. That's what this elastic tissue is for. So as the heart contracts, it's going to send a lot of blood into these elastic arteries, and they expand in response to that, and then they recoil while the heart is relaxing. Then we have muscular arteries. These are sometimes called distributing arteries. These distribute blood to the skeletal muscles and to organs. And then arterioles are the smallest arteries, and they lead to capillaries. Capillaries are the smallest blood vessels, and they are where nutrient exchange happens. So nutrient exchange happens in these capillaries. Then they lead to venules. The venules collect blood from the capillaries and lead to the veins. And the veins bring blood back to the heart. So let's talk next about arteries. Two major types, capillaries. Two major types of capillaries. We have continuous capillaries, such as this one, which is the most common. They're found all throughout the body. Nutrient exchange happens by diffusion. You can see the wall is very thin here, so oxygen, whatever nutrients they can diffuse through here, water can diffuse here very easily, and vesicle transport happens as well to move things either in or out of the blood. Only small molecules can leave from these type of capillaries, things like oxygen or glucose or water. Then the next type is a fenestrated capillary. Fenestrated capillaries have small holes, and these holes allow faster exchange of water and nutrients. Things as small as, or things as big as small proteins can leave through these holes. And then we've got holes for larger things to go through, and it makes it easier for water to go through. You would find these in the kidneys and in endocrine glands. And then another type are called sinusoids, or sometimes they're called sinusoidal capillaries. They have these large spaces in between the cells. So large proteins or even whole cells could leave or enter there. These are found in the liver, the spleen, the bone marrow. The bone marrow is where we're producing new blood cells, and they get in through these holes. The new blood cells get in there. And then in the liver or the spleen, old and damaged red blood cells can leave through these holes and then be recycled by macrophages. Alright, this is a capillary bed. Capillary beds supply nutrients to a specific tissue. And capillary beds often receive blood from more than one artery, called a collateral artery. You can see here there's two arteries coming to this particular capillary bed. It's kind of like an insurance policy. So if this capillary gets blocked, you're still going to have blood coming to it. So we have lots of these in places like the brain, where adequate blood flow is necessary for our survival. The entrance to capillaries are guided by what's called a precapillary sphincter, which is a ring of smooth muscle cells, and they can constrict to close off that capillary. So right now you're probably sitting down and you don't need a lot of blood going to your legs, but there's lots of blood going to your brain. So the capillaries, some of the capillaries in your legs might be closed off right now. There's no blood traveling through there. It just travels here through this meta-arterial or through this arteriovenous anastomosis. And when you're running a marathon, these will be open and lots of blood is going to your legs. So that's capillaries. Next we're going to talk about veins. Veins have low pressure and they contain most of the body's blood volume. You can see most of the blood is in the systemic and venous system, 64%. And that's because the veins have a bigger diameter. They're sometimes called pressure volume reservoirs, and the arteries are called pressure reservoirs. And since there's low pressure in veins, the movement of blood is assisted by one-way valves. You can see an example of one of these valves here on the leg. Also skeletal muscle contractions and the pulsing of nearby arteries. So when this muscle contracts, it squeezes on the blood in this vein. It can't go backwards, it can only go this way, back towards the heart. And that is what happens. And because of these valves, blood can return to the heart without using much energy. It only has to move the blood from here to here instead of from your toe all the way up to your heart. If the blood volume drops, veins can constrict to maintain normal blood pressure. They do have some smooth muscle outside of them. And that's what this is showing. They're innervated by the sympathetic nervous system. So they will constrict to help regulate our blood pressure. Do that to increase our blood pressure. And this is a diagram of blood flow through the body. Again, we've got the pulmonary circuit and the systemic circuit. Unlike most arteries, the pulmonary arteries carry deoxygenated blood. So that's green. Most arteries are carrying oxygenated blood. Pulmonary arteries are carrying the deoxygenated blood to the lungs where it picks up oxygen. I would mention, here's again the fetal circulation blood. Pulmonary arteries take blood to the lungs where carbon dioxide leaves the blood and oxygen enters the blood. Next we want to talk about the pulmonary circulation. The fetal circulation. It has modifications to bypass the lungs because the fetal lungs are not functional yet. The fetus gets all its nutrients from the placenta, including its oxygen. There's no oxygen in its lungs, so they're not working yet. So a couple of structures you should know. The foramen ovale is right here. It allows blood to pass from the right atrium to the left atrium. And then another structure you should know is right here, the ductus arteriosus. This allows blood to travel from the pulmonary artery to to the aorta right here. And in this way, it doesn't have to go to the lungs and back to the heart. And at birth, these both close off, and that allows blood to flow to the lungs. Then there are a couple of defects you need to know here. This shows the foraminal wall has closed and the ductus arteriosus closes. So the defects we need to know. A ventricular septal defect is when there's a hole between the two ventricles. So here's the hole. Oxygenated and deoxygenated blood are going to mix, and that leads to problems. This one is called patent foramen ovale, and this is when the foramen ovale doesn't close. So now you've got a hole between your atria. And this also shows our patent ductus arteriosus. Ductus arteriosus doesn't close off. This one shows tetralogy of Fallot. This is when the pulmonary trunk is narrow. And the interventricular septum right here is incomplete. Then an atrioventricular septal defect is when the atria and the ventricles are not completely separated. So and then we have transposition of the great vessels. This is when the aorta, the pulmonary artery is attached to the left ventricle and the aorta is attached to the right ventricle. Normally the aorta is attached to the left ventricle and the pulmonary artery is attached to the right ventricle. And we'll talk about the heart in the next chapter, but you'll see that the left side of the heart is much bigger because normally it's pumping blood out to the whole body, where the right side just has to pump it to the lungs. So with this transposition of the great vessels, that's backwards, and you've got the bigger part of the heart pumping blood to the lungs, and the right side is not strong enough to pump blood all throughout the whole body. So that's blood vessels. The rest of the chapter is the anatomy of different blood vessels. Moving on that would just be boring, so you can read that on your own. Again, let me know if there's anything that's not clear.